Question number 28, derived from ray optics, and there's a combination of two lenses separated by a certain distance, focal lengths being same, object at 20 centimeter. The lens are separated by a distance of 2 centimeter. And we need to calculate the final position of image as well as the nature. If you see the option, whether real, virtual, that has been asked. So all I need to do is that I need to go stepwise. First, let's see for the lens formula. 1 by V is 1 by F plus 1 by U. Now let's go for the convex lens. 1 by V is going to be 1 by 5, and the object distance is 20 centimeter with a negative sign. Considering the sign convention, that's not a big deal. So here what I will be getting is V equals to 20 by 3. So that's positive, which is 6 point something. That means the image of the convex lens would have formed somewhere here had it not been for the concave lens. So if the concave lens was not there, image would form somewhere here because this distance is 20. But that image of the convex lens will act as the object for concave lens now. So let's now talk about the object distance for the concave lens. So now let me go for the concave. U would be equals to, see, from here it's 20 by 3 and 20 by 3 minus of 2. So that's going to be 14 by 3. That's the object distance for the concave lens. So that's towards the right. And for the concave lens now, 1 by V is 1 by focal length, which is minus 1 by 5, plus 1 by U. So that's plus of 3 by 14. So that is the given position of the image, and that is what we need to calculate. All right, now if I calculate this expression, the value of V is going to be plus of 70 centimeter. Therefore, the image will be 70 centimeter to the right of B, and that would clearly be a real image. So the correct option for this question is going to be option number 2. Fine, now let's move to the penultimate question. Question number 29, that is brought from electrostatic and capacitive circuit, which is very clear here. It says that initially the switch was at position A. Now the switch is shifted to position B. And after it is shifted to position B, we need to calculate the energy dissipated, which of course is in the form of heat. And that energy dissipated in terms of the total charge Q. So total charge Q is, of course, the initial charge that it collected from this given situation. So here, see, to solve this, the expression of heat, I expect that every one of you know it, and that is half C1 C2 by C1 plus C2 into V1 minus V2 whole square, where V1 V2 are the initial potential difference. So half C1 C2 by C1 plus C2, so that's going to be 4C, and V1 minus V2 whole square, so that will be E square, and that is 3C E square by 8. But then we want this given expression in terms of Q. So Q is the charge when the capacitor was connected across E, and that is CE. Therefore, this expression straightway comes as 3Q square by 8C. Just putting Q equals to CE. So option number 1 stands out to be the correct for question number 29. Now let's go for the final question of this shift. Fine, the final question of this shift. So an arrangement is given there, minus 2Q, Q and Q, and we need to calculate the dipole moment of this system vectorially. So in order to model it into a dipole format, we'll take this as minus Q. So one pair would be here, another pair would be here. So this one pair is P and this is another P, and that P, of course, is Q multiplied by L. That's the magnitude of the dipole moment. Clearly, the net dipole moment would be in this direction, and that is a straightforward. You could say the angle between them is 60 degree. So if you calculate the magnitude, yes, so that will be equals to root 3 times P. Because P and adding by parallelogram, that's a very straightforward thing. And put the value of P as QL, and the direction is in the negative J cap. So the correct option for this is going to be option number 3. All right, with this discussion, now we end up the discussion of physics paper that had been asked on 12th January 2019 morning shift. So if you were the one who appeared for the question paper, I wish all the best. And if you are a viewer who is yet to appear for JEE Main and who is an aspirant, I believe the video was quite helpful. And apart from simply visualizing the numerical part, time and again, I was discussing about the nature and the psychology of the question paper related to JEE Main. So take all those things, get maximum benefit. All the best. Thanks for watching. Thank you very much.